Hello everyone, welcome to Homework Help. If you find the video useful, please subscribe to the channel. In this video, we'll solve this related rates word problem. As per the problem, water is pouring into a cylinder at a rate of pi meter cube per minute. The height and the diameter of the base of the cylinder are both 10 meters. How fast is the water level rising when the depth of the water in the cylinder is 8 meters? The first step is to draw a diagram for this problem. We should draw a cylinder. Water is being poured in the cylinder. As water is poured in the cylinder, the height of the water column increases. Let's assume the height of the water column at a particular point in time is h. Let's assume the radius of the cylinder is r. As per the problem, water is being poured in the cylinder at a rate of pi meter cube per minute. That means dV over dt is equal to pi meter cube per minute. The volume of water in this cylinder is changing at a rate of pi meter cube per minute. In this problem, we need to find how fast the water level is rising in the cylinder when the depth of the water is 8 meters. That means we have to find the value of dH over dt when the height of the water in the cylinder is 8. Since we are given the value of dV over dt, we should use the formula for volume of a cylinder to find dH over dt. The formula for volume of a cylinder is pi r square h. As water is added in the cylinder, the radius of the water column doesn't change. That's why the value of r is a constant in this equation. The diameter of the base of the cylinder is 10, so the radius of the water column in the cylinder is equal to 10 over 2, which is equal to 5, and the unit is meters. But the value of h is not a constant because as more water is added, the depth of the water in the cylinder increases. This is a very important concept we need to understand and memorize. Since the value of r is a constant, we can sub in r as 5 in the volume formula. Five square is equal to 25. Next, we should find the derivative of this equation with respect to time to find dH over dt. On the left side, the derivative of v with respect to t is dv over dt. On the right side, 25 pi is a constant. It's the coefficient of the term, so it will stay as it is. The derivative of h with respect to t is dH over dt. In this problem, we are given that dV over dt is equal to pi. We can isolate dH over dt by dividing both sides by 25 pi. On the right side, the pi's cancel each other out. So I get dH over dt equals 1 over 25. And the unit is meters per minute because the rate of change for volume is meter cube per minute. This should be the final answer for this problem. As per the problem, we have to find how fast is the water level rising when the depth of the water in the cylinder is 8 meters. We do not have to use this value in this problem because dH over dt is not dependent on the depth of the water in the cylinder. That's why we did not use 8 meters to solve this problem. This is a very important concept we need to understand to solve this type of problem. So these are the steps you have to keep in mind to solve a problem like this one. I hope you'll find this video useful. Please share it, like it, and subscribe to Homework Help. Thank you very much and have a nice day. Bye.